All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Neil Armstrong reporting the roll and pitch program, which puts Apollo 11 on a proper heading.
The waiting is over. Oh Lord, I'm somebody, I'm like desperate with singing, but you know the problem is I cannot really sing. So, but they say practice makes perfect, so I'm hoping that I will practice more and in due time I will be perfect. This is another episode of The Void. Thank you so much for connecting with us. You can actually be part of this conversation by liking our page, by following our page. It's a Facebook page, and the handle is at The Void Show with Andrew. It's at The Void Show with Andrew. So make sure that you search that and you follow the page so that you do not miss any episode from The Void Show. My name is Andrew Falati Khomu, and this is Active FM. As they always say, radio has never been better. Okay, so I am so excited. I have always been excited about what we're going to speak about today, because we are taking this journey through the deep space and discover more about the expansion of the universe. Is the universe really expanding? That's what we're talking about. And I should do say that this topic for today was influenced by lots of questions that I got from so many people. And a funny thing, when they come and ask me, what I have come to realize is that the objective of them asking is not to understand the expansion of the universe, but it's to argue. And, you know, almost every reason for arguing is that I do not hear what you're saying. What I'm saying is right. And so that's the point. That's the funny thing. It's to argue. But worry no more, because today we will be discovering more about the expansion of the universe. We cannot make you believe what science say about the expansion of the universe, but really it can only be and ever be on how compelling the evidence is to you. The evidence is to you. There's what we call a scientific method in science, and so it's almost what every scientist goes through when they are discovering new things, when they are it's an everyday thing, you know, it's an automatic thing. The thing is, it makes you not to believe something that is false when it's actually true, or something that is actually true when it's false. So that's the point of the scientific method. So today we will be actually looking at the evidence behind the expansion of the universe. And really, you have to be open-minded. A lot of people just look up and Google for 7 minutes and they conclude that scientists don't really know what they're speaking about. But actually, that's okay. I mean, it's okay for people to have questions about science and the discoveries of science. But today, be open-minded and really understand. I emphasized this point in the last episode. It's very important to have a fundamental understanding of what we're talking about, rather than just knowing or always arguing, finding something to argue about. So just find something and understand what we're talking about, and actually say, okay, so this is what science say, and this is what we can actually do from this point onwards. It's a complex thing that I will try by all means to not go through the complexities of it, but find something that is analogous to the expansion of the universe. You can find us on Active FM website. It's www.activefm.co.za. So right after this, I will be talking more about that, so make sure that you stick with us.
The wait is over. Hold on tight. We are in the overdrive. Welcome. This is your favorite station. Stay tuned. Turn up the volume. The volume.
3, 2, 1.
Active FM, this is The Void Show. I always say that it's the only show that brings the imagination of the whole universe through your radio stations to your minds. Another episode of The Void Show, the exciting Void Show. And on this episode, we are talking about the universe expansion. Is the universe really expanding? I mean, it sounds ridiculous, I know, and I remember, like, for the first time I learned about the expansion of the universe, I was like, what on earth are you talking about? How can you even start to imagine the expanding universe? And if it's expanding, what is it expanding into? And so I would really love to hear what you're thinking about the expansion of the universe. Is it your first time hearing about the expansion of the universe? And if it's your first time, the expansion of the universe is like one of the best discoveries, one of the triumphs in science. And there's obviously much more complicated stuff behind the expansion of the universe. We speak about things like dark energy, dark matter, and obviously redshift and blue shift. But I will not focus on some of those things right now, but I will definitely make another episode where I discuss that in more depth. But today, what I want to do is to give you evidence about the expanding universe, because the most important thing is for you to have a fundamental understanding of the universe, which is what I really believe that our educational system should be focusing on, to not only teach our students what to think, but to teach them how to think about these things, to take them through a journey where they learn how to learn. That's the most important thing. And I should say that almost everyone who came to me is like skeptical about these things, and that's okay to be like that. It's okay. It's actually a good characteristics to ask questions about these things. So make sure that you tell us what you are thinking, or what are you thinking about the expansion of the universe. And if you have any questions, make sure that you send them on our Facebook official page of The Void. It's at The Void Show with Andrew, and we will definitely answer them. So I will make a very feasible and suitable example before we understand the expansion of the universe. So, for example, let us think that you are standing on a road, okay? You are just standing at some point on a road, right? Or in a way, any point actually, but you are just standing there. And 1 kilometer away from you, there is an ambulance that's standing, that's waiting. So there's an ambulance that is stationary at that point, right? So it's you are standing at some point across the road, and there is an ambulance 1 kilometer away from yourself. And so the driver of the ambulance starts to ring the siren, right? The wheel, that's emergency siren. So it starts to ring, it starts to play in all directions, right? It definitely sounds in all directions. But listen to this. When you are only stationary and the ambulance is stationary 1 kilometer away from you, you are going to hear the same sound, right? There's not going to be a change in the sound that you are hearing. So you definitely hear the same sound, right? Why? That's because you are stationary and the ambulance is stationary. Remember what we said. You have yourself in a road, and 1 kilometer away from you, there is an ambulance. And the driver in the ambulance starts to play the siren, right? Whew, whew. We are saying that you will definitely hear the same sound, same frequency, because both of you guys are stationary, right? But let's think it like this. Let us think that the driver starts to move the ambulance towards you. The driver of the ambulance starts to move the ambulance towards yourself. Tell me what's going to happen to the sound. What are you going to hear? As the ambulance approaches you, you will definitely hear an increase now and then of the frequency, of the pitch of the sound. But where the ambulance had to move, if the ambulance had to move away from you, what was going to happen? The sound will definitely diminish bit by bit until you no longer hear it. Is that okay? Right? And so to understand why we think about sound waves, and this is a scientific way to think about sound actually, but it's actually true. Sound travels as waves. And how did we know that sound travels as waves? It really goes much more in depth, but to just give you a clue on what's happening, how the sound travel, how did we actually know that it travels as waves? So this is what happened. We looked at what happens when sound passes through a medium, right? We looked at what happens when sound passes through a medium. And what we observed was that there was this back and forth movement of particles of the medium through which the sound is moving. And to be honest, that can only be waves that are making this back and forth movement. Let's make an example. If you have water, and maybe you have water filled in a bath, right? And so you can actually do this an example in your own time. If you have water that's filled in a bath and you just place a floating material on top of water, you have to make sure that it's floating. It could be a paper or it could be something. Make sure that the water is still. When you throw in a pebble inside the water, what's going to happen? You're going to see these waves, these beautiful waves, right? And look at the paper or that material that you placed on top of the water. It should be floating. What it's going to do, it's going to be moving up and down. Why is that happening? It's because of the waves, right? There are those waves. So it's pretty much the same thing when it comes to sound. We had sound moving through a medium, and what we saw was the particles that made that medium. We saw the particles moving back and forth, and so we concluded that these are supposed to actually be waves, sound waves. We call them mechanical waves. So we want to think about this in a more scientific way on what happens when the ambulance gets towards you. Remember, we said you are standing in a road, maybe at some point in the road, and 1 kilometer away there's an ambulance, and so if it's going to move towards you, you're definitely going to hear the sound, the frequency, the pitch of the siren increasing a bit by bit. And so what happens scientifically? Why do you hear this sound increasing bit by bit? Remember that from the ambulance, because the sound is emitted in all directions, so it's moving in all directions. There are these waves, beautiful waves moving in all directions. When the ambulance gets towards you, why do we have an increase in frequency? That's because when it starts to move towards you, the waves, they start to get closer and closer to each other, and so they start to be squeezed up and bunch up between you and the sound source. And because of that, they increase the frequency, so the energy increases, and obviously the pitch will definitely increase. What happens is the sound waves, they bunch up in front of each other in a phenomenal way, and so that causes the frequency to increase. But had the ambulance had to move away from you, what was going to happen to the sound waves? The sound waves are going to be stretched, so there was going to be stretch, and there's what we call wavelength. It's actually some property of waves. It was going to be stretched, and so if it stretches away from you, that causes the wavelength to increase but the energy to decrease. So if the energy decreases, the pitch also diminishes bit by bit. And this is a principle actually that we we call a Doppler effect. It's the Doppler effect, and it's an effect that results because of the moving away of sound source and the observer or who's listening to the sound. So that's actually what happens. We call that process, the whole thing that's happening, we call it Doppler effect. It's a principle, and you've got to be very careful about the principles and laws of nature. We speak about like things like laws of gravity and all that stuff. These things explain the regularity, right? They explain the regularity. I've never encountered any law or principle that create things, right? That create things. And I should do say my opinion here. A lot of people do say that laws of the universal laws actually create things, right? I was actually watching a video, and it was a debate, and some great scientists, they were debating about a statement that Stephen Hawking made, that because there is a law of gravity, the universe will and create itself. It will and can create itself. And so that really sounded like a contradiction, because I mean, if you look at laws of nature, they only they explain the regularity. If an object moves up, it will definitely go down. That's a regularity. It does not create any new thing that's happening in the situation. So it's the same thing as the Doppler effect. It explains what happens when you have a sound source and an observer, and so the sound source is moving either towards or away from the observer. He will hear an increase in sound if the sound source is moving towards you, and if it's moving away from you, you will definitely hear the diminishing sound of the sound, right? Yes. So that's the first thing that you should understand. It's called the Doppler effect. And so I want you to understand that first, and I'm going to play this beautiful, amazing jam from Reactive. And after this, I'm going to tell you how does that or how is it actually analogous to the expansion of the universe. So make sure that you understand the Doppler effect. Remember, I will repeat again. You have yourself, you standing in a road, and you have a sound source some kilometers away from you. And so if the sound source is moving towards you, you will definitely hear an increasing pitch of the sound, right? It will definitely sound louder and louder and louder if it's moving towards you, and if it's moving away from you, the sound will diminish bit by bit, gradually. So that's just the concept that you should understand. It's called the Doppler effect. It's a principle. It describes the regularity. And so please just understand that. If you have not understood that, make sure you go back to the beginning and hear it again, understand it. And after this nice gem by Reactive, I will definitely explain how is that analogous to the expansion of the universe. Make sure that you tell us what you're thinking on our social media pages. It's at The Void Show with Andrew. Otherwise, you can find us on Twitter, the Active FM Active FM Twitter handle is at Active FM. So make sure that you go there and you tell us what you're thinking about the Void Show. Now here's a song by Reactive, I Cry Out. Enjoy.
9, 8, 7, 6, 5, 4, 3, 2, are you ready?
You can stream Reactive's very own The Movement album on Spotify and Apple iTunes. Reactive is a movement.
Out of the darkness. up in the dark, unable to guard my heart. God, you turned it around, discovered the lost, now I'm found. I cry out of the darkness. I'm recovered. You're my hero, Jesus. Through all Jesus went through, you went ahead and made me new without fault. I'll apply your healing salt. Through all Jesus went through, you went ahead and made me new without fault. I'll apply your healing salt.
And that was a gem by Reactive saying to you, I cry out. I hope you did enjoy and hopefully you did understand what we spoke about in the first part, the Doppler Effect. The Doppler Effect, and if you did not get it, make sure that you go back and understand it, because that is like feasible, it's fitting, it's analogous, it's a very good thing to use in the case of the expansion of the universe. So make sure that you tell us what you're thinking about the expansion of the universe. We have pages, just search Active FM, you will definitely find it. On Instagram it's at Active FM 777, so make sure that you go there as well and you like that page. So on the case of the expansion of the universe, Doppler effect causes a similar shifts in light waves, and you have to be very careful because I'm now putting in the picture a new name, light waves. So it's pretty much the same thing, it's sound waves and it's light waves, right? And so because we both in these names have waves, it means that both of them have similar properties. I mean, they are waves either way, so they have to have similar properties. The difference is that it's sound waves in the case of an ambulance, and in the case of stars or galaxies, it's what? It's light waves. Okay, so let's do this. Let's say this. Let us assume that we have a galaxy at some point in the universe, right? And let's definitely assume that the galaxy is stationary. By the way, everything in the universe is moving relative to something else in the universe, so nothing is really stationary, everything is moving relative to something else in the universe. So we're just assuming, right? Because it makes sense when we assume things like that. So let us assume that we have a galaxy at a certain point in the universe, right? And you are definitely on Earth. And so because we're speaking about the light waves, remember that these galaxies emit light in all the directions, so there will definitely be light that's moving from that galaxy to Earth, right? To yourself, to your eye, right? That's the thing. Now, if the galaxy is stationary and you are stationary, so if both of you guys are stationary, remember that in the case of an ambulance, we said that you will definitely hear the same sound, right? There will be no difference in pitch of the sound or the frequency of the sound because both of you guys are stationary, so it wouldn't make sense to hear differences in sound because both of you guys are stationary, so you will definitely hear the same sound coming towards you. It's the same thing with the galaxy. I mean, both of you are stationary, so you will definitely get the same amount of light that's coming towards you. So the waves will be the same. The light waves will move from the galaxy to you in the same way. There will be no differences in the wavelength. It will definitely be the same, and you will get the same frequency of light from that galaxy coming towards you. But what if the galaxy was moving away from you? Remember that we're speaking about waves. What if the galaxy is continuously moving away from you? think about what's going to happen to the sound waves. It's definitely the same thing that happens to the light waves. Now, because the galaxy is moving away from you, let us say maybe this galaxy, it's 14 billion years away from you. I mean, not 14 billion years, but 14 billion light years away from yourself, right? 14 billion light years away from yourself. So what astronomers observe, if we look at this galaxy this year and it's 14 billion light years away from us, at this time next year, if we look at it, it's now 15 billion light years away from us. What does that mean? It means that it's moving away from us. And when we check the light waves, we actually see that these waves, they have actually stretched with some amount. They have actually stretched with some amount. So we say the wavelength, the length of the wave, it has increased to some point. And so we say, because this is what we actually see. This is what we actually see with every other galaxy that we're looking at. They are all moving away from each other. They are all moving away from ourselves. And we should be very careful, because people are like, or at least I've heard a lot of people saying that, okay, why are we not expanding? Look, it's the universe that is expanding. It's not us. So us, there are forces that hold us, which are very, very strong at our scales compared to the force that expands the universe. So we have to be very careful of that as well. It's the universe that is expanding. So that's what we see. You look at every other direction, you see these galaxies moving away from each other. It's the light waves that are stretching. Okay, and there comes in the picture the concept of redshift and blue shift. So redshift is basically a shift that happens in the spectrum of whatever celestial object that you're looking at. And when we're speaking of a spectrum, we are speaking of the electromagnetic spectrum. You have to be very careful that Newton at some point in his life discovered the light that is beyond light that our eyes can see. We speak about X-ray, infrared, ultraviolet. You've heard that we're running away from ultraviolet. You do not see ultraviolet. You can't see it. We only limited. Our eyes are only restricted to see visible light. We do not see ultraviolet light. You can't see X-ray. So you need particular or specific telescopes in order to see those kind of lights. You only know that there's ultraviolet light, UV rays, but you cannot see them. The light that you can only see is visible light. You need to know that there's light beyond that. And so when galaxies take out light in maybe a whole amount of the electromagnetic spectrum, so it can either be X-ray, visible light, infrared, and all that stuff. So blue shift is basically a shift that happens in the waves of these galaxies when they are moving away from each other. So what happens, because in the visible light, when you check the wavelength is much greater in the red end of the spectrum, and it's much higher in the blue end of the spectrum. So because of that, when you look at the galaxy now and then, we see that, okay, so the absorption lines that actually happen, and I will make a episode about this, because it's not explaining it much better, but then it goes more in depth about this. Blue shift and red shift, it's just the shift that happens when a galaxy is either moving towards us or away from us. And be very, very careful. They are not moving towards us or away from us. That's also very, very, very key to know. They are not moving towards us or away from us. So if you go to Andromeda Galaxy, or you go to other galaxy, these weird names galaxy, you will see the exact same thing. It's not that these other stars or these other galaxies are moving away from us, right? They are not moving out. Yes, it might appear like they are moving away from us, and you think that we're in a special place and you feel good about yourself, but they are not. You go to other galaxy, you will see the same thing. So you'll see all of them moving away from yourself. So a good example for this is if you bake muffins, or whatever that you bake, and you put in these raisins in those muffins, right? So when you put them in the oven, what's going to happen when they start expanding? They all expand, right? And if you were to stand on a specific raisin, when you look at all the other raisins, it will appear as if they are moving away from you, but actually everything is moving away from each other. Right? Everything is moving away from each other. Another analogy for this is if you take a balloon and you just put some dots on it, right? And you blow it. When you blow it, and when you maybe assume that you are standing at a certain point that you just plotted on the balloon, and you look all the other dots, it will seem like they are moving away from you. And actually, you're not special because everything is moving away from everything else. So we then concluded that the universe should be expanding, and that's actually one of the reasons the scientists talk about the Big Bang, because we see the universe expanding now. That should mean that at some point back in time it was much smaller, and so they said it started with a bang. And let me tell you my opinion, what I think about the Big Bang. The Big Bang, I tell you that it has 150% probability statistically of being correct, accurate. It has that. We have a lot of people who do not understand what is the Big Bang, and so they just conclude that we can't have it. But I tell you now, according to me, it has 150% chance of being correct. But what I find to be weird, to be ridiculous, is that they claim, or actually it is said that the universe came from nothing or nothingness, whatever. That's what I find to be ridiculous, because the Big Bang only explains the origin and the evolution of the universe. So the Big Bang is just the name that's given to a phenomena that was believed to have started the universe, and the Big Bang cosmology describes the evolution of the universe. That's okay. But then to say that the universe began from nothing, that's the most stupid thing that I've ever heard. And tell me what you're thinking about the Big Bang. If you don't understand the Big Bang, tell me. I will make an episode about that. Make sure that you comment on all our social media platforms. And I loved the show today. If you loved it, tell us that you loved it. And right after this, I will definitely be closing.
Hey, this is Naomi from Reactive, where music isn't just a band, isn't just a single person, but it's a movement, it's a lifestyle. You're listening to Active FM. Radio has never been better.
Yes, and that was the end of it for today. It was a great show, and I hope that you enjoyed it. Make sure that you catch us on all our social media platforms, www.activefm.co.za. Twitter is at ActiveFM, and Facebook /ActiveFM, and Instagram is at ActiveFM777, and The Void Show Facebook official page is at The Void Show with Andrew. That's where you get all the episodes. That's where you get everything. So make sure that you follow the page, you like us, so that we keep getting more information, and you tell us what you're thinking about every topic that we're speaking about on The Void Show. We on iTunes, Apple Podcast. We're on Spotify and TikTok as well. Active FM is there. You can just search Active FM. And from myself, I'm leaving the studio. Thank you. Have a good week ahead of you. Same time, same place next week.
The one radio. You tune in on your way home. This is The One.
Now on air. It's the award-winning radio program.
This is The One. The one for fun and entertainment. The One.
Are you ready?
The one you listen to all day. This is The One.